Hi students, welcome to our science class. Our chapter name is Essentials for Life, Air and Water. In the last few classes we are discussing about air, its properties, and we also discussed about atmosphere, which are the different layers of atmosphere, and then discussed about air, which are the things included. That means which are the components for the air and all the things we discussed, and finally we reached on the topic properties of air. Properties of air. First property we already discussed. Which was the first property? The first property is this: air occupy space. That means air needs space. For that we discussed one activity, that just take one bucket of water and fill it with half water, and then take one glass and now invert this glass directly to our bucket of water. And when I am putting this glass inside the water without tilting, that means straight I am pulling this to the water, what happens? You can see that the water do not enter the glass, but when I am tilting this glass, that means when I am keeping this glass inside the water. When it is straight, no water will be there enter inside the glass. But when I just tilt this, what happens when I just tilt this? What happens? You can see number of bubbles will come, and then the water will enter to the glass. What is the bubble? Bubble is nothing but the air filled in the glass. So using this activity we can say that air occupies space. We already mentioned this activity in the last class, and also I just asked you to do this activity. I hope you completed that and understood what is this. Now we are going to the second property. This is the first one. Air occupies space. That means air needs space. That is the first one. The second one is this: air has weight. So the thing is this: air have weight. Do this air have weight? We are just looking it as a question. Air has weight. I am just putting my hand like this, and on my hand they have air. Do that air have any type of weight, or do this air is weightless? What you are thinking? For that we want to do one activity using two balloons and one stick. We can discuss that. Before that we are just doing another activity using this weight. At first, inside this there is nothing. That means this is empty. This is nothing there. Only this plain plate is there left. And now you can see this is straight. This stick is straight. The reason is this: they are balanced. That means inside this and inside this nothing is there, and so we can say they are balanced. The weight of these two plates are equal. And now you can see that I am going to put some balls inside this. I am just taking some balls. Here I am going to put some balls inside this. Just taking this and put 1, 2, 3, 4. Now you can see that this plate is at bottom side. That means this stick is now tilted. Why? The reason is this: now here nothing is there, but here we just put some balls. That means because of the weight of this ball, it is getting tilted. And when I am putting the balls inside this, you can see that I am just taking one here. Now both of the things are balanced. Both of them are equal weight on both of the plates, and you can see this stick is also straight. Why? Because now inside this plate 3 balls are there, and here also 3 balls are there. That means the weight of this and weight of this both are equal. That means when the weight of these two are equal, you can see the stick is straight. When we are just taking out these balls from this, what happens? The stick will tilt. That means the weight is unequal. This is the thing we are going to do within the activity of air. Just put it in your mind. Whenever the weight of the things are unequal, then what happens? It will get tilt like this. Just put it in your mind. Nothing is there. So, for checking, our aim is this: do the air is having weight. Here we just did that. Just take 2 weights and we just put some of the balls here, and we know this balls having weight. And when the weight of these 2 plates with the balls are equal, they are just straight. Now I am just taking a stick, tying it with a thread, and tie here and here 2 balloons which are equally filled with air. That means same size the balloons. So here I am just putting 1 balloon, another balloon. Both of them are filled with equal amount of air. And the thing is this, they are balanced. The reason is this: within this air, within this balloon and within this balloon, we are adding equal amount of air. And because of that, the rod is, or the stick is straight. Now, I am going to take a pin and touch on this. And what happens when I just take a pin and pricking this? What happens? This balloon will that balloon had gone. So now, do this stick will still be like this? No, you can see that this stick will now the stick will be like this. That means our stick is now tilted. Why? The reason is this: now within this balloon no air is filled, but for this balloon it is filled with air. So the thing is very simple. We studied within the activity using the balls. When I am taking this ball out, we can see that this is getting into down, or they are getting tilted. Why? The reason is this: when I am taking this empty, this bowl, that means I am removing the weight from this. In the similar way, we can say that when I am taking out the air from this balloon, what happens? Here also the weight is getting unbalanced. The thing is this: if there is no weight for the air, nothing will happen. They will still remain the same. But here you can see the instability, or the stick is just tilted because of the weight of the air. Now we can say within this balloon air is there, and that air is having weight. But here no air is there, and so that air is having, no air is there means no weight. So that's why this is getting tilted. So that is the activity that mentioned in your textbook. Just read it, nothing is there. So you just want to remember what air has weight. It is not a question. This is one statement, and it is right that we can say air has weight. Air is not weightless. Air has its own weight. So that is the second property. Now we are going to discuss the third property, and it is air can be compressed. Air can be compressed. For that, within a beaker, I am just taking some gas. I am just taking some gas. We know within the gas, it is having molecules. We already studied that. These are molecules or particles. Now I am going to do that. Just take one piston. Piston means the thing that we can see on the syringe and all. So I am just taking one piston and giving force on this side. When I am pressing this, what happens? Then we can see that the molecules are getting closer. The molecules are getting closer. First, it is like this, and when I am giving force, these molecules are getting closer. And now this piston moves to this point. Nothing is the thing, only we are mentioning that we can compress the air. That means when we are giving pressure on the gas, what happens? The molecules are getting closer. And the thing is this, we can say it is compressed or it can be compressible. We can compress the air. So that is the thing. For that you just remember, this is the activity. We are just taking the air within a beaker and taking one piston and giving pressure. When we are giving pressure, what happens? The molecules are getting closer. So we can say when these molecules are closer, then we can say that they only need less space than the initial stage. That means at first our piston was here. That means at initial stage this gas molecules needs more space. But when the compression occurs, when we are giving compression, when we are giving force, what happens? Then they are tilted, or when they are just fitted in smaller area. That means they can fit in the small region. That's all. So we can say air can be compressed. We can give force and they can get into compressed. So that is the third point. Now we can discuss about the fourth point about the air, and that is also very simple. For air expands on heating and contracts on cooling. Actually, we studied about the expansion and contraction. How this expansion occurs, that we studied in our previous chapter and all. So the thing is this, again, within the beaker we are taking the air. And so we know I am heating this. First of all, our molecules are like this. And when I am giving heat, what happens? We know when we are heating the matter, what happens? There occurs expansion. So these molecules are moving away. At first, our gas is only this much, but when I am heating this, what happens? They are getting expanded, and so they need more space. So we can say on heating, for air there occurs expansion. As similar as other matters, we know when we are heating the solid substances, they got expanded. In the similar way, for the air also there occurs expansion. And the next is, now I am cooling this. I am cooling this. What happens? Now you can see that these molecules will come closer. That is, at initial stage our gas is this much, and when we are cooling this, what happens? They are getting contract. That means they are compressing into a particular region, they are contracting. So this is what the fourth point. So we can say air expands on heating. When we are heating this, the expansion occurs, and when we are cooling this, what happens? The occurs contraction. So very simple. That is the fourth point. And now we are going to discuss the fifth point, and that is the last one. Air exerts pressure. Air exerts pressure. How this air exerts pressure? Generally, any substances which have weight exerts pressure. That is the basic thing. And so you just understand like that. What substance which have weight exerts pressure? We said that air has weight. So we can say this air also exerts pressure. Very simple. So what thing have weight give pressure, and because of that air have weight, and so we can say air give pressure. That is the fifth property. Very simple. And here you want to remember, within this pressure exerted by the air, we want to study one term. The properties of air is completed here, and now we are focusing on a particular term, and that is the atmospheric pressure. Atmospheric pressure. Very simple. What is this atmospheric pressure? The atmospheric pressure is this, the pressure exerted by air is called atmospheric pressure. So the thing is very simple. The pressure exerted by air is called what? Atmospheric pressure. That means what pressure is exerted by air have a particular name, and that is what? Atmospheric pressure. We know within the atmosphere it have air and all, and so this air is giving pressure, and that pressure is what? Atmospheric pressure. Very simple. Just remember this definition. And what is the importance of atmospheric pressure? That means within what region this atmospheric pressure help us? It is also very simple. Using this atmospheric pressure, within your textbook they are just mentioning about the explanation and all. No need of that things. You just want to remember these examples. That's all. So for this atmospheric pressure, that means using this atmospheric pressure, some sort of things are happening in our daily life. The thing is this, we can fill up a syringe. We can fill up a syringe. Another, we can fill ink in fountain pen. Another, the working of droppers drinking with straw, etc. So these are the examples that we are utilizing the atmospheric pressure. The thing is this, we can fill up a syringe. That means you all already observe the syringe. First, what is the filled inside the syringe? You know nothing is the inside the syringe. It is filled with air. Inside this it is filled with air. And how this is filling with some sort of liquid or something? When I am just putting the syringe inside the water, is it okay? No. How is it possible? For that, first I just want to push this. I want to push this down. So you can see that this syringe is just moving to this side like this. our head will be here, and when I am pulling this, what happens? When the syringe is moving to this direction, when I am moving the syringe to this direction, what happens? The liquid inside this beaker is getting inserted to the syringe. Who is acting there? Actually, within this syringe there acts the atmospheric pressure. Actually, the difference with the higher atmospheric pressure and lower atmospheric pressure, the liquid is flowing to the lower pressure. No need of thinking of that. Now you just want to study these examples only. No need of worrying what is happening inside the syringe. No need of thinking that. So that happens this. That means when we are just pulling the syringe, there what happens? The pressure is less inside the syringe. So the water is getting enter inside this. That's happening. No need of studying that. Just next, filling ink in fountain pen. The same thing happens. When we are pressing, what happens? The air inside the tube is escaping out, and there how ink is getting into the fountain pen. Same thing happens for the working of droppers and also for drinking water with straw. When we are just sucking in, what happens? The air inside the straw is first taking into our mouth, and then the atmospheric pressure is less, and so what happens? That's how the water is entering to the straw. Nothing is there. These are the important. So the uses that we are utilizing the atmospheric pressure. Nothing is there. Just remember these things. These examples. That's all. And just read the textbook. That's enough. And the next is water. The next is water. So we studied everything about air. We know the basic thing, the very essential thing for our life. First is what? Air. And the second thing is nothing but the water. Water is also very essential for all the living organisms like plants, animals, human beings, insects, like everything. Whatever, even if it's have life, so it needs water. Generally I am saying that. So we can say the first thing it is essential is air, and the second thing is water. So we can say this is our earth, and when we are cutting our total earth into 4 pieces, these 3 regions are filled with what? Water. They are filled with water, and this is only the other region. That means we can say within our earth 3/4 of our whole earth is covered with water. And the question is this: do all this water is possible to drink? No. Within the whole water, only 3% is possible to drink. That means the other 97% of water is the ocean water or sea water. That means that water is salty. That means the water contains salt. So the thing is very simple. Only possible to drink this 3% water and this 97%. That means most of the water is not possible to drink. Only the 3% is possible to drink, and the whole 97% is not possible to drink. And why? The reason is this: they are salty. We know the ocean water, the sea water, everything is having salt. So that is the thing. And now the question is this: where we are getting this water? We get the water from river, ponds, then lake, and rivers are there, ponds are there, lakes are there. All these are filled water by how? With raining. So we we can say basically the water is coming to our earth by the raining, and it is continuously happens the evaporation of water from the river, ponds, lakes, and they are just on the sky and getting condensated. Condensation means the water is getting cool and then again coming as rain. Actually it is a cycle. That means the rain is coming and then the water is evaporating. Continuously happens. And so we can say within the river, ponds, lakes and all, the rainwater occurs. And also where we are getting the water within our home, we get the water within the well. And also we are using some sort of thing called hand pump. So the thing is this, we get the water from river, ponds, lakes, well, hand pump, etc. So the thing is this, we get water from different sources, and the thing is this is about the basic things about water, and we want to study about some sort of impurities and all that is mixed in water. That means actually we get the water is not pure. Some sort of impurities are there mixed inside our water, and that we can study in our next class. So just read your textbook, and also you want to complete your notebook. We can meet in the next class with the impurities that is going to mix on the water and all, and they have its own classifications. We will meet in the next class with further topics. Thank you.